On the day of their review, learners returned to the National Space Centre to consult with the customer and receive advice from industry professionals about their designs.
The motor's going to go here.
Yes.
The circuit will be here, but I want to save space, so I'm going to put a circuit on top of a circuit.
Okay.
And the battery's going to go there, and the steering's going to be here.
Okay, is it going to have 4 wheels or 3?
4.
It's going to have 4.
So they came here for their first meeting where we introduced them to the design concept, and then they've gone away for the last 8 or 9 weeks, and then today they came back to follow through to show us how far they'd got.
This is just a concept photograph that we have put together of the Mars yard, but it's going to be 10 metres long and 6 metres wide. And it's going to have this hillock in the middle, about 30 degrees, so your rover has to go up that angle of 30 degrees, which is one of the criteria that we said. So this is the actual surface that we're going to have made. This is actually concrete and then dyed these particular colours to make it look very much like the Martian surface. So your Martian rover is going to have to go along a surface like this.
Chris spoke to me and he showed me what the Mars yard is going to be made from. That helps a bit because I know what to expect, what my Mars Rover will have to drive over.
Chris had a word with us about what we're supposed to do and how the Mars surface is going to look. So after that, I just researched about how I can increase my torque on my Mars Rover.
You know the problem you'll have there if you do it like that, yeah? Same thing as a motorbike.
It was good. I got to talk with the technicians and kind of showed me a few things about how I should go about my problems with the kind of like building the Mars Rover, because I had a kind of like a complicated suspension system which I was having difficulty with it, but he showed me a few things on how to kind of like solve it, which was a great help.
I was pleased to see what some of the students had done on their CAD designs and some of the manufacturing of the axles and the wheels, and some of them had some very good ideas about what they're going to do and how they're actually going to propel this rover across the Mars yard, which they're coming to do in the summer term next year. So we're hoping that's going to be really good.
Saying a 4-wheel vehicle driven by 1 wheel, if that wheel comes off the ground because of the terrain, you've lost traction. A 3-wheel vehicle, you can always guarantee the back wheel, if it's a driven wheel, is always in contact with the terrain. So you have options. I'm not saying that is the solution, but...
Yeah, the wheels are a slight problem, but as I said, once I can make some smaller models, I can perhaps look at what sort of wheel system will work best and what's going to drive best over this sort of terrain.
Did you find this rather interesting to do? Have you done this sort of thing before?
This has been quite an interesting project this year because obviously it's the first time we've done it and it takes time, but that's far outweighed by the benefits for the students in terms of seeing how collaboration with other organisations has helped develop a whole range of skills, motivate the students, put the whole thing in a real life context.
But there are a lot of other companies out there that would be willing, I'm sure, to work with colleges on projects such as this type of idea.
You've got to look, I think, at what employers or large employers or institutions you've got locally and try and set up partnerships with those.
Is there any other help that the Space Centre can give you in any way, shape or form?
Perhaps some sort of technical advice. I think it's good that the course is delivered for a project, because when you're doing each subject in a classroom, you can sort of see how that relates to what you would be doing in real life if you're using this sort of theory.